Hi, I'm Larry Shea, president of ATS Products. Our company makes fiberglass reinforced plastic duct intended to be used for the exhaust of corrosive vapors. Plastics have a well-known problem. They can burn, sometimes rapidly, and generate much smoke. A benchmark used widely by insurance companies to assess the value of different systems is a test created and conducted by Factory Mutual Research. In this test, effort is made to burn a plastic duct a distance of 24 feet in 15 minutes. A fire source is placed at one end of the duct and a fan is connected to the other end. The fan is started and the fire is lit off. In 1985, we contracted with the Fire Research Laboratory of the University of California to conduct comparative tests on ours and some of our competitors' products. The only involvement of our company was to fund the securing of materials and the conductance of the tests. Competitors' materials were purchased through conventional channels with the provisos that the products furnished were to have low flame and smoke ratings, were to be listed by Factory Mutual Research, and that the products were to be marked and identified with certain code or FM listings if they applied. All products were subjected to the Factory Mutual number 4922 duct test standard. Here we see the draft shield with the pan of heptane, the 25-foot length of duct, and the fan and discharge from the room. Factory Mutual examining the Factory Mutual label. The countdown to ignition, which is at 5 minutes after the hour. Light smoke coming from the duct is that of heptane. Note that in all tests, ATS duct was used on the discharge of the fan to evacuate the smoke to the outside of the building. It's now 3 minutes into the test.
Get mad. Goodbye. Get mad.
Well, they catch that smoke. This is beautiful.
Well, the antimony trioxide that they use to cut down the flame spread of it is a known carcinogen.
That's low smoke rating. That has a low smoke rating.
Got a smoke density of 50, Dennis.
Yeah. Sure does.
Yeah, that's 50.
It's now 4 minutes and 25 seconds into the test. The exterior of the duct is starting to smoke. It's 5 minutes and 37 seconds.
The flame out the back.
It's 7 minutes and 37 seconds into the test. 8 minutes and 10 seconds. 8 minutes and 40 seconds. It's now 11 minutes into the test. At 11 minutes and 9 seconds into the test, note the flame jump over the duct. Note that the smoke from the exterior of the duct is moving backward toward the booth because of the action of the room exhaust fan. This is similar to what would be expected from recirculating air fans above clean rooms. duct commences to collapse. It's 11 minutes and 37 seconds into the test. Note, a duct can collapse like this and still be considered to have passed Factory Mutual's fire test, but not the smoke removal test. At 12 minutes and 10 seconds into the test, an effort is made to extinguish the ductwork with a CO2 extinguisher. The duct continues to burn because it is its own source of fuel. It also continues to generate very large quantities of dense black smoke from its interior. The duct continues to burn on its own because it is not self-extinguishing. Since the duct has collapsed, it would have been disconnected from the wet bench in a clean room. Rather than aiding and exhausting the smoke and toxic gases from the clean room, the collapse would have aggravated the problem. The three ducts you see tested here today are the best industry has to offer. You can imagine what happens with ducts that ignite more readily and burn more rapidly. Some codes and insurance standards require fire protection sprinklers be installed at ducts connected to equipment. However, sprinklers have some definite drawbacks. The sprinkler acts as a damper, shutting off airflow in the duct, causing smoke and toxic gases to back up into the clean room. Tests conducted at the University of California for Intel Corp show that combustible ducts ignite and burn up to the sprinklers. The duct burns through and collapses, thereby cutting off the bench ventilation. When the ventilation is breached, the fire seeks an air supply, flares up, and causes extensive contamination. Smoke detectors, regardless of their locations, only react after the contamination has occurred. Isn't it more sensible to avoid the use of sprinklers if possible and exhaust the heat, smoke, and toxic gases from the fire area? Which state that the product is FM approved and supposedly listed by ICBO and tested to UL 181 standards. Ignition occurs at 24 minutes and 17 seconds after 5 p.m. In anticipation of smoke, the fans are started almost at once. At 51 seconds into the test, note the light heptane smoke coming through the discharge of the duct. This was true for all three tests conducted. It is nighttime, and a spotlight is used to show smoke coming from the ductwork. It's now 2 minutes into the test. Note that the interior of the duct is already catching on fire and will sustain itself hereafter. It needs no external fuel source. 15 seconds later, black smoke starts coming from the interior of the duct. While the smoke is quite black, it looks white because of the spotlight on it. You can see particles of soot raining onto the ground. At 3 minutes and 39 seconds into the test, the exterior of the duct starts to smoke. Note that the smoke is moving toward the exhaust fan, which would happen with the recirculating air fan in a clean room facility. If one is to stay in the test room, an air pack must be worn. The obscurity in the test room got so bad you could not see the duct. It's now 8 minutes into the test. At 8 minutes and 50 seconds into the test, fire is seen near the fan inlet, and there is a call to discontinue the test. 9 minutes and 23 seconds, effort is made to extinguish the heptane fire, and this is accomplished 25 seconds later when the screen shows 33.39. Note, even though the fire has been extinguished, the exterior of the duct still smokes. Test is concluded. We go on to the next test, that of the ATS duct. Here we see the ATS label. Countdown to ignition, which occurs at 3 minutes 35 seconds after the hour.
5, 6, 7, 8, 9, 3.
This is the real neat part about his duct, is the quantity of smoke is zip.
Again, we see the very light white smoke from the heptane fuel.
It's really...
Excuse me, I want to get a shot in there. Zoom in. Thank you.
5 minutes and 15 seconds into the test, the duct exterior commences to smoke. After 6 minutes into the test, note the lack of obscurity, the lightness of the smoke, and the fact that the room exhaust fan has not had to be turned on. At 7 minutes and 15 seconds into the test, some burning starts to occur on the exterior of the duct. If you look in the lower right-hand corner of the screen clock time shows that it started at 10:54.
You're in the video. Thank you.
By 11 minutes and 54 seconds, the burning was just about complete. And at 12 minutes and 14 seconds, the burning stopped completely. A total elapsed time of 1 minute and 20 seconds, or 8 minutes and 35 seconds into the test. All the action is over. Note the clarity in the room. No one has to wear masks. There is no further progressive burning during this test, and most of the light white smoke coming off the duct exterior is steam. The resin system has carbonized as it is supposed to do. This is what prevents any further flaming of the duct system.
We got a nice cherry red shot there.
It'd be interesting to know what the outside temperature of that duct is right there.
Well, it's cherry red. So I'd say it's around 1600 Fahrenheit. Well, we got it all recorded in there.
The inside, that's thermocouple is taking the inside temperature.
Yeah, I know. But okay, that's 15 minutes. We gotta go 18. We gotta go.
This shot shows the same quantity of smoke coming from the duct which occurred all during the test. There was never any increase beyond this, and it is primarily the heptane smoke exiting from the ductwork. At 14 minutes into the test, no significant smoke evolution has occurred within the room. No one is wearing a mask. The room fan is still not turned on. Note when the fire is extinguished, the duct itself is not on fire, though temperatures had reached 1950 degrees Fahrenheit. The official 15-minute test is now concluded. All of these tests were run at 600 foot per minute velocity, which is one of the two velocities specified by Factory Mutual. FM requires that ducts be tested at both 600 and 2,000 foot per minute velocities. It has been found in the past that the 600 foot per minute velocity is the worst case condition, and is the reason why all of these tests were conducted at that velocity. The air velocity within this duct will now be increased to 2,000 foot per minute to show that under that condition, the duct does not collapse or close off in any way and is suitable for smoke removal from clean room areas. Note that no portion of the ductwork has collapsed, even that adjacent to the booth has remained in place to do its job. There is no smoke in the room after 21 minutes into the test. One can see why it is important to have a duct that's rated for smoke removal and also does not generate much in the way of smoke. The test will now be concluded.